This is Mr. Smith, and in this video I'm going to go over the Test 5 review. In fact, this first part, we won't get all the way through it in one shot, so it's going to end up being two videos. So let's go ahead and get started. It says in problems 1 through 4, determine whether or not each statement or each sentence is a statement. Now remember, a sentence, to be a statement, it has to be true or false, but not both. It's got to be clear. It's either true or it's false. The other thing is things that are not statements be questions, commands, or opinions. So do your homework. That's a command, so that is not a statement. The average human brain contains 1 billion neurons. I don't know if that's true or false, but it is a statement. It's one or the other. So yes. Lionel Messi is the U.S. president. Well, that's certainly a false statement, but yes, it is a statement. What is the meaning of life? That's definitely a question, and so that would not be a statement. All right. Let P and Q and R represent the following simple statements. It is cold outside, we sit by the fire, we go to the movies. So, for example, here you have not P, so it is not cold outside. And this is the and statement. And R, we go to the movies. So that's how all of these work. Now you got to be a little careful about these ones where you have a not in front of Q, or well, you have these two, this or statement here in parentheses. The way we translate this is it is not the case, or we say it is not true that, so Q is we sit by the fire, or we go to the movies. So again, you want to translate the not in front of parentheses as it is not true. And then notice here it's what's in here that we're stating. We sit by the fire or we go to the movies. All right, so if you haven't already done the others, I would encourage you to do those. I'm going to go ahead and put up the answer for those. So for 7, you should have, if it is cold outside and we sit by the fire, notice the comma after we have the parentheses, then we do not go to the movies. Notice this is an if-then statement. If you have this, it's cold outside and we sit by the fire, then we do not go to the movies. Number 8, we do not go to the movies. That's not R. If and only if it is not cold outside, or we sit by the fire. All right, let's move on. So now we're going the opposite direction. And let me get organized here. So I'm registered to vote. That's statement P. I'm a citizen. Statement Q, I vote. Statement R. So these are our simple statements. Express each English statement in symbolic form. If I am a citizen, so this is an if-then statement. If I am a citizen, that's Q, then I vote, that's R. So if R, then Q. So again, I would encourage you to do these if you haven't already tried them, and then check your work. All right, let's see how you did. So I am registered to vote and I am a citizen, and then you see the comma, that means parentheses. Put it around parentheses, or I don't vote, or I do not vote. So that'd be not R. I vote, that's R, If and only if, that's this symbol. I am not a citizen, that's not Q. Or I am registered to vote, that would be P. If I am not registered to vote and I am not a citizen, then notice again it's an if-then statement. That's why I have the arrow here. So if this, then I do not vote. That would be not R. All right, let's move on to the next page. Let's see. It says, express the quantified statement in an equivalent way. Some students love school. And what we discussed about this is if some students love school, then at least one student loves school. Well, that's what this says here. Now notice at least one student does not love school. That's not the same as the meaning here. So it's close. It's the opposite, actually. All right. I wouldn't even say it's actually the opposite, but it doesn't have equivalent meaning to this one here. When we say some students love school, that indicates that there's at least one that loves school. So this is the best translation. All right, let's move on to 14 through 17. So here's where we're going to want to get out our cheat sheet. So all houses are made with wood. So that's an all are A, B statement. To negate that, we'll say some A are not B. So in this case, some houses are not made with wood. Now, one way that you can kind of check to see how you're doing and if your statement seems reasonable is one of these statements should be true and the other one should be false. All houses are made with wood. Now, I think that's certainly the majority for houses in the United States. But, you know, there are houses that are made of strictly brick and mortar. I would say it'd be kind of hard to find some of those, but there are such houses. Certainly you can go down to Mexico and find some of those. And I don't know, there might be other types, but basically if we say that this is a false statement, then this should be true. Some houses are not made with wood. Well, that would be the example I just mentioned. So they do have opposite truth values. This would be true, this would be false. So no students major in business. So here we have no A or B. So we want to get the opposite statement, some A or B. So some students major in business. We're just using let's see, it was no A or B. We're using some A or B. So no students major in business, that's certainly false. Some students major in business, that would be true. There's at least one. Number 16, some crimes are motivated by anger. So that would be a some A or B. To negate that, we would say no A or B. So no crimes are motivated by anger. And finally, some apples are not red. So there's your some A are not B. And to negate that, we'll say all A or B, or in this case, all apples are red. Well, some apples are not red. That's false. I'm sorry, that's true. I'm doing this late at night and I'm getting tired, I think. So some apples are not red. That's true. All apples are red. That would be false. So you can see they do have opposite truth values. Okay. So let's complete these sentences here. Not P has the opposite truth value of P. P and Q is true only when P and Q are true. I'm assuming you've already gone through these. I'm just checking your work with you. P or Q is false only when P and Q are false. P implies Q, or if P then Q, is false only when P is true and Q is false. P if and only if Q is true when P and Q have the same truth values. And finally, a tautology is a compound statement that is always true. All right, so in the next 4 problems, we're going to complete truth tables, and we want to determine whether we have a tautology or not. It turns out that this is going to be no, 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 and yes. And so if you've already done that, you can confirm that those are your answers. I'm going to go ahead and fill out the truth tables, and then we'll come back to 28. Okay, so on number 24, we're going to complete the truth table. So we have P, not P will have the opposite truth value, so we'll have false, false, and true, true. Not Q will have the opposite truth values. We'll have false, true, false, true. So not P and Q, so we're going to AND these 2 statements here. That's a conjunction. It doesn't really matter the order. We just know that an AND statement is only true when they're both true, so that would be here. Notice there's no other cases where they're both true, so these are false. And finally, we have P or not P and Q. So we're basically going to use this statement here and this one here. Now if you wanted to, you could put P right here and just write the truth values here. But what I did here will work. We just want to focus on these 2 columns here. Remember, an OR statement it's usually true. It's only false if both statements are false. So we're looking at these 2 columns. So do we have any 2 falses? There you go, right there. So that's false. We have true, true, true. Oh goodness, where do I have that? All right. Need to get organized here. Okay. So let's move on to the other 3. Now again, I would encourage you to try these if you haven't already. It's easy to watch me do it, but you want to make sure that you're comfortable doing it yourself. So here we have not P, so it's going to be the opposite of our P column, so false, false, true, true. Now not P or Q, we're going to do an OR statement with these 2 columns here. Again, it doesn't really matter the order. We know an OR statement is only going to be false if both statements are false, so that's here. Now in all the other cases, we don't have false, false. We have at least 1 true. So these are all true, and that one's false because of the false, false. All right, so finally, we want to know if P implies this statement here. So we want to know if P implies what we have here. So remember, an if-then statement is usually true. It's only false when you have true, false. So there's your true false. So this is false. And that's the only true false. We have true true, true false, false true, and false true. So the others are true. Again, notice it's not a tautology, but that is our final answer basically for this statement. All right, let's move down to number 26. Of course, not Q is going to be false true, false true. And then P, if and only if not Q. Well, remember, this statement will be true if they're both the same. They're both false or they're both true. We have true false here, so that's false. True true, so that'll be true. False false, that'll be true. They're both false. Here they were both true. And these are not the same, so this will be false. And so this is our answer. And again, you can see with all of these three that we've done, they're not tautologies because we didn't get all true statements. If we have a statement like this and the last column is all true, it doesn't matter what P and Q are, the statement is a true statement. All right, last one on number 27. We're going to have to build the statement ourselves. So we have P and then we have Q. We're going to need P or Q. We're just going to kind of build this from left to right. We're going to need not P or Q to build this statement. And then, so now we have this one here. So now we need to build this one here. We're going to need not P and not Q. And then we'll have not P and not Q. And then finally we have the whole statement. Not P or Q implies, or if not P or Q, then not P and not Q. Okay, so now we're ready to do this. So you can see how we step by step build up to the complete statement here. So P or Q we know is false if they're both false. Otherwise we're true. So this is the only false false. So not P or Q will be the opposite of our P or Q table, or truth values. So false, 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 true. Not P is the opposite of our P column. So false, false, true, true. Not Q will have false, true, false, true. So now we're going to do an AND statement with these two here, not P and not Q. We know AND statements will be true if both statements are true. There's no other case where they're both true, so these are false. So finally, we get to the final statement here. We want to know if not P or Q implies not P and not Q. So this is an if-then statement, so it's only false if we get a true false. So true false, we're looking at these two columns here. We want to know if this one implies this one. We have false false, false false, false false, and true true. Notice we don't have any true falses, so these are all true. So this is a tautology. All right, so let's wrap things up here. We got one more problem to do for this first part. All right, so on number 28, it says determine the truth value for each statement when P is true, Q is false, and R is false. So Q is false, and R is false. So this is a true statement because it's an if and only if statement, and both P and, or in this case Q and R, are both the same. So this is a true statement, but we have a not here. So not a true statement, we're going to get a false statement. Here, P is true, Q is false, and R is false. All right, so just focus on this part here. We know an AND statement is only true if they're both true, so this is false, implies. And here we have T or true or false with an OR statement. Remember, OR statements are usually true unless both statements are false, so this is true. Now we have false. If we have a false implies true, remember with conditional statements, they're only false if you have true false. And so this is a true statement. All right, and that's it for this first part of the review for test 5.